Okay, and finally, in our last part of section 5.2, we're going to do the go backwards problem. So in other words, instead of starting with the function and finding the graph, we're going to start with the graph and try to write the function. So we have two examples to work through. The things to think about when you're doing this are your intercepts and that end behavior. So we know that the end behavior in this first example, they're starting and stopping on opposite sides, and that's going to tell us that it needs to be an x to an odd degree. So it's an odd power function, basically. As our zeros, which are those x-intercepts, we have one at the origin, we have one at positive one, and we have one at 2. It is crossing at each one of those, so that means as factors, they all occur just one time. They occur an odd number of times, in the easiest case is 1. So when I go to write my polynomial function, I'm going to do f of x is equal to a. That's my leading coefficient. I'll have an x minus 0, an x minus 1, and an x minus 2. Again, what we're recognizing is that if x equals 1 is a solution and you bring the 1 over with the x, you're going to switch it somewhere. You don't really need to write the 0 there. So we're going to have ax times x minus 1 times x minus 2. Now, I will not ask you to expand it out. The online homework may want it in expanded form, in which case you're going to take a few minutes to multiply that thing out. What about a? Well, a is the leading coefficient. And in order to find a, we need a second point on that graph. And this particular picture doesn't give me another point to use. Some of the ones in your homework may give you another point. So for instance, if there is another point over here and that point is labeled as, I don't know, 3,16, you would then replace the x's with 3's, set it equal to 16, and find the a value. So you can do it. They just didn't give us enough information on this particular example to be able to find a. So what the book technically does, or usually does, is it assumes the easiest case, and it'll tell us to let a equal 1 in the directions. If it doesn't tell you that, then you have to go find a, but they have to give you another point that is not necessarily an x-intercept in order to be able to do that. What about part B on that one? So we're going to know a couple of things. So again, let's talk about zeros and the power function. So in terms of a power function, this guy is starting and stopping on the same side of the x-axis, which means it has to be an even power function, but it's starting and stopping below, which means it's a negative of an even power function. So we think that we're going to end up with a negative x to the 4th. How do I know it's not an x squared? Because I don't see my parabola shape, and the next smallest even number is a 4. So we're thinking it's a negative x to the 4th. So our zeros are at negative 2, 0, again, the origin, and also over at positive 1. It's crossing here, but it's bouncing at that 0 and crossing here. So this tells me that this has to have an even multiplicity. So as we build our function, we're going to throw in that a again. We're going to have an x plus 2 that's coming from this negative 2. We're going to have an x minus 0 squared. That's that bounce that's happening at the origin. And then we'll have an x minus 1. And to clean that up, I have my a. This is an x squared. I'm going to pull it out in front because it just looks better there. Times an x plus 2 times an x minus 1. Again, if they had given me another value or another point on this graph, it wouldn't matter what it is. If they were to give me another x and y, I can replace x with that value, set it equal to y, and find a. We're going to, again, in this example, assume that a is equal to 1. But don't forget, in general, I'm going to make you go find that a. So just like we did when we did the parabolas, clear back in chapter 4. And that wraps up section 5.2 for us. We are going to do the rest of the chapter out of order. So we're going to skip up to section 5.6 next. We will then backtrack and do, we'll do 5.6, then 5.7. Then we'll backtrack and pick up 5.3, 5.4, and 5.5, because they kind of all go together. I don't know why they're in the middle of all the polynomial stuff, but we'll skip to 5.6 next.